Okay, so let us practice this Test-1A. It's quite simple. Okay, so balancing chemical equation. Let me read the question once. From the following word equation, form the balanced chemical equation. So there is a word equation given. For example, the first one we can start with is the word equation is given as, you can follow me as we write, magnesium in solid form burns or react with oxygen in the gaseous form to give us magnesium oxide. So here magnesium oxide, which is in the solid form. So we are writing it down, the first one, to show how we are exactly will be answering this question. Okay, so here this is called a word equation. It is written in English with plus in between the reactants and the products also. So this chemical equation has a left hand side, okay, and it is written in the English language, and the ones on the left hand side of this arrow marks are called reactants, okay, and after they react, whatever we get on the right side of the equation or the arrow mark are called products. As I said, I repeat, the ones on the right side of the arrow mark after the reaction has completed are called products, and the ones on the left hand side are called reactants. So to be to take the specific reactants and products, here magnesium and oxygen gas, which are on the left, are therefore reactants, and our product here is the magnesium oxide. So when we write a chemical equation in this manner, where we write the names in the English words without using symbols, such is called a word equation. And the question is saying, change this word equation into a balanced chemical equation. So the first step to do it, that is to change the word equation first to skeletal equation. So what is a skeletal equation? The symbol for magnesium is Mg. Okay, so we write in the symbolic form. It is derived from the first and the third letter of the English name magnesium, and then specify the solid, so we may as well write it. If it's written in the question, it's good to write it. And here oxygen in the symbolic form is O2. It's in the gaseous form. Here let me note one thing here. When we write like this, we will call this as magnesium, this one, or magnesium atom. Okay, and when we see something like this, this is called magnesium ion. So they are not specifying the ion, so we are supposed to write the atom, which never have charge. Atoms never have charge, keep that in mind. Okay, then here let me also specify this. When we write, see a symbol like this, this is called oxygen atom. Okay, oxygen atom without any charge, single. Then when we see here at the top 2 minus, that's called an oxide ion. Anything having positive or negative charge is an ion, right? So, and then when we see like this, this is called oxygen or oxygen gas. Oxygen or oxygen, so gas. So since they are saying oxygen, write O2, and then we just write the same thing, arrow, and then magnesium oxide is a compound. So we recall our starter and write the formula, and we know magnesium ion is Mg 2+, so keep that in our imagination. Then oxide ion is O2-, so here 2 valency, here also 2-, 2+, they will cancel, so 1 will come down, 1 can be brought down, but since it's 1 reduced to 1, we do not show that, we do not write that. Okay, so this is called the magnesium oxide. So we have here this very equation that we have written here using the word equation in the symbolic form is called a skeletal equation. Now here, skeletal equation needs to be changed to balanced now. Now, I'll just write the skeletal equation once more, just to make things clear in the first one. Okay, from the second one, we will be doing shortcut. Okay, so here, a skeletal equation is an equation written in a symbolic form from the word equation usually, and the skeletal equation may be already balanced or may not have been balanced. So let us check. At the back, no number means 1. So there is magnesium 1 atom on the left side, 1 magnesium atom on the left side of the arrow. On the right side, at the back, no number, so 1 magnesium atom. So there are equal number of magnesium atoms on the left and the right. So that's called balanced equation. So far, so magnesium atom is balanced, equal both sides. So we go to the next one. So how do we balance chemical equation is what we're discussing here. The only way to do that is by trial and error. So we begin with one atom, balance it, go to the next. That is the most usual way of balancing. And there is no fixed method to balance a chemical equation. It's only by trial and error, which means the more we practice, the more we'll get the idea, and balancing chemical equation will become relatively quite easy. Okay, so 70 to 80% of chemical equations are not at all difficult to balance. About few of them we need to be a little bit more careful, but they are also not that difficult. Okay, so we need to practice more and it becomes something that we can handle quite easily. Okay, so here next is how to see how many oxygen atoms are there, or any other atom for that matter. We always check the back. Okay, and then at the back there's 2 means on the left side 2 oxygen atom. Here at the back, right, there is no number, then just go to the back. If there is a number right in front, we need to note that also. But since there is no such number here, 1, no number means 1. So on the right, 1 oxygen atom. On the left, 2 oxygen atom. Okay, which means they are not equal. So to make it equal, we usually increase the bigger one. So bigger one is, increase the smaller one. 1 is smaller, so we put right in front, 2 ones are 2 oxygen. So on the right side, now there are 2 oxygen atoms. On the left side, 2, so they are balanced now. So that's how we balance an atom which is not balanced on both sides. So this is called balancing of equation. Simply put, the number of each type of atom on the left side should be equal to the number of the same type of atoms on the right side. Okay. Now balancing therefore should be right in front. So if we put the number here and balance 2, that's wrong. We are not allowed to balance from the back. We are also not allowed to balance in between. We have to balance right in front of the molecule or the compound. So 2 ones are 2 oxygen on the right side and the 2 oxygen atoms on the left. But the problem with that is, since you put it right in front, 2 now belongs to both magnesium and oxygen atoms on the right side. Means magnesium atom on the right side has increased because of that to 2 magnesium atoms on the right side. So the left side, which is 1, also has to be increased to 2 to make it equal. Now, so the equation is now balanced. There are 2 types of atoms, magnesium and oxygen, on the left side. The same atom will appear on the right side, only magnesium atom. No new atoms will appear. Like on the left side, magnesium and oxygen atoms are there. Suddenly you see on the right side, chlorine atom. It's not possible in a chemical equation. So whatever types of atoms are there on the left side will be seen only on the right side, nothing more, and whatever is on the left side will also not disappear. Impossible. Okay, and then balancing equation means the number of each types of atoms that you see on the left side should be exactly equal to the number of atoms of the same type on the right side. So this is now like that. So this is a balanced chemical equation. Now let us read the balanced chemical equation now. So here, before we read it, just remember this. At the back of a symbol, if there is no number, means it's 1. If it's 1, that means it is an atom. Any substance having more than 1 atom, whether same type or different type. This O2 means in oxygen, the 2 oxygen atoms are connected by a double bond, which is not necessary to show, okay, but I'm just explaining here. So since there are 2 oxygen atoms, we call this as molecule, because anything more than 1 atom, same type or different type, molecule. Only 1 atom like this one, Mg at the back, no number, not front, okay. 2 magnesium atoms, we know that, but at the back, no number, then there's an atom. At the back, 2, so there are 2 atoms, so the molecule. Here also at the back, 1, but here is another one, 1. So this molecule MgO has 1 plus 1, two atoms, one magnesium atom, one oxygen atom, that makes two atoms make magnesium oxide. So it's a molecule, atom. So let's now read. Therefore, we'll read two atoms of magnesium reacts or burns in one molecule of oxygen or oxygen gas to give us two molecules of, because there are two atoms, 1 plus 1, magnesium oxide. So that's how we read a chemical balanced equation. Let's go to 2. Red hot iron. So let's just do this a bit, keep some space. Now this writing this one here, red hot iron, is not compulsory, okay, in the exam, but I will advise you or encourage you to write, because as you write both the name and the symbol and the formula, you'll get a better grasp of how to handle a chemical equation and thereby find it easier to balance also. So red hot iron plus, put a little bit above, and steam is passed, so just write here steam and then arrow, this arrow plus on the same line. Now let's write the formula. Iron is derived from the Latin name ferrum, the first two letters. So iron, red hot or cold also. Symbol is Fe. The question is saying in the solid form. So this is red hot, put it in the fire, the iron nail, and it's red hot. That time you pass steam means the gaseous form of water. So the same chemical formula as water. G at the back of H2 is called steam. L at the back of H2 is water, liquid. So when you pass steam over red hot iron, the question is saying it gives iron 2,3 oxide. So let's write here iron 2, 3. Oh, not there, sorry. A little bit below the arrow. Iron 2, 3 oxide. Now this is not the usual inorganic compound. This is a complex of two inorganic compounds. First, let us take this one, iron 2 oxide. So iron 2 oxide is, iron 2 ion is Fe2 plus, oxide ion is O2, so 2 cancel, so 1, 1. That's the formula of iron 2 oxide. Combine that with the next one, iron 3 oxide. So iron 3 ion is Fe3 plus, oxide ion is O2 minus, so 3 and 2 can cancel, so 2 at the top of O will go to the lower backside of Fe. 3 at the top of Fe, iron 3 ion, will go at the back of lower backside of O. So this is the formula for iron 3 oxide, lower one. And this one is the formula for iron 2 oxide. So this is how we write the formula. We combine them as if we're adding two numbers, O1 plus O3, O4, Fe2 plus Fe1, Fe3. So the formula of the complex iron 2, 3 oxide is Fe3O4. It's in the solid form, question is specified. So here, iron 2, 3 oxide and hydrogen, so plus hydrogen. Below the plus, you write hydrogen. As we have been saying, when we say, write like this is hydrogen atom, the symbol for atom. When we write like this, we know this. Yes, hydrogen ion. Then when we write like this, hydride ion, yes, you already know from your starter, right? But when we write like this is called hydrogen or hydrogen gas. So we write hydrogen means always H2. Question is written in the word equation as gaseous form. So this is the skeletal equation. So next we change the word equation to skeletal equation, means symbolic form, and then we balance it. There are the two steps. Change the word to skeletal equation and then convert the skeletal equation to balanced chemical equation by making each type of atoms on the left side equal to the right side by trial and error method. Okay, so here let us do that. Let us see here. On the left side at the back, no number, so 1 iron atom on the left side. On the right side, 3 iron atom. So how do we balance? Yes, we make, common sense also tells us that increase the lower one 1 to 3 to match the higher one. So we put here 3 right and 5 because we are not allowed to balance from the back, nor are we allowed to balance from in between the atoms. So 3 Fe on the left side, which is exactly equal to 3 iron atoms on the right side. Now, let's go to H. There are 2 here on the left side. Here also 2. So far okay. So 2 iron atom, 2. So far equal, balanced. But as we go to the next one, O at the back, this 2 is the subscript. The ones at the back are called subscript or smaller numbers. Will always belong to the front symbol, 2 hydrogen atom and not 2 oxygen. How many oxygen atom will always be told by the back, just as how many hydrogen atom is told by the back number 2 hydrogen atom. So at the back no number means 1 oxygen atom on the left side, and here 4 oxygen atom on the right side. So increase the 1 to 4 by putting here right in front, because we're not allowed to balance from the back. The 4 ones are 4 oxygen atom now on the left side, which is exactly equal to 4 oxygen atom on the right side. Okay. Then once we do that, hydrogen is disturbed. So 4 2s are now not 2, but sorry, this is hydrogen previously. 2 hydrogen and here 2 hydrogen. I wrote Fe, sorry. Hydrogen. Now on the left side it has become 8. 4 2s are 8 hydrogen atom. So this also has to be made equal. 4 2s are. And when we write like that, we write the front number is called the main script. So we write it slightly bigger than the back one. Okay, bigger size. Main script wide in front. At the back is smaller numbers, smaller size numbers. So 4 2s are 8 on the right hand side also. So it's now balanced. Every atom on the left side of each type are now exactly equal to the number of the same types of atoms on the right side. That is called a balanced chemical equation. This is our answer. So let us read it. At the back here, only 1. So we call this one atom. We don't need to write, okay? I'm writing, you just follow. At the back here 2, here 1. So not to see whether a thing is a molecule or an atom, don't count the front ones. Back 2 plus 1. 3 atoms make steam. 3 plus 4, 7 atoms. So this is molecule. This is also, don't write, okay, molecule. And at the back 2 means more than 1, so molecule, atom. So let us read the balanced chemical equation. 3 atoms of iron reacts with 4 molecules of steam to give us no number in front means 1. So 1 molecule of iron 2,3 oxide and 4 molecules of hydrogen. Okay, I hope you're picking up, right? Okay, next one, number 3. So here carbon monoxide plus hydrogen on the left side. So a little bit below you, right? Carbon monoxide plus, a little bit below the plus hydrogen on the left side. Hydrogen therefore H2 is mentioned as gas. So carbon monoxide also mentioned as gas to give us methanol on the right side. So arrow here and a little bit below the arrow write the name also, which is not absolutely necessary but good to write. So methanol is not an inorganic compound, it's an organic compound. So just write the formula by memorization from your memory. CH3OH, memorize that. Okay, now here we see it's a skeletal equation. So we have the balance. How many carbon on the left side? 1 carbon atom. C means carbon atom. On the right side also 1 carbon atom. Left side, how many O? 1. Because there is no O here, 1 oxygen. On the right side also the back here. This 3 doesn't belong to O, it belongs to the front one. Is a subscript H. So 1 O, balanced. H2 on the left side and here 3 plus here no number 1. So 4 hydrogen atom on the right side. So 3 plus 1, 4 hydrogen on the left side. To make it 4, therefore make it slightly bigger than the subscript 2. 2 2s are 4 hydrogen atom. Now hydrogen atom balanced. So here now let us count once. 1 carbon, 1 carbon, 1 oxygen, 1 oxygen. 2 2s are 4 hydrogen. 3 plus 1, 4 hydrogen. So this is a balanced chemical equation. Let's now sort out whether these are molecules, which are molecules and which are atoms. Back here 1 and 1, so 2, so molecule. 2, so molecule. 1, 3, 4, 5, 6 atoms, so molecule. Everything is molecule here. So let us read. As we said, let us remind ourselves. The compounds on the left side are called, yes, reactants, and the right side are called products. So the reactants here are carbon monoxide and hydrogen, and the product is methanol. Okay, so 1 molecule of carbon monoxide reacts with 2 molecules of hydrogen to give us 1 molecule of methanol. Number 3. Okay, let's go to 4. here. Number 4. Carbon dioxide plus water gives you, in the presence of sunlight and chloroform. This is photosynthesis. Carbon dioxide and water in the presence of chlorophyll, means the green color pigment in plants, green plants, and in the presence of sunlight, these two green plants can manufacture their own food, right? So carbon dioxide in the gaseous form, they are saying, so CO2, we know G at the back. Water in the liquid form, we know water is in liquid. The presence of sunlight and chlorophyll produce their own food called glucose. So write the glucose, and there is no trick to write this formula so far yet, so just write C6H12O6. Keep it in your memory. Glucose in the aqueous form means dissolved in water. Then the three products are oxygen in the aqueous form means oxygen O2. So you write here oxygen dissolved in water is called aqueous form. These two should be written slightly below, okay? And water in the liquid form. So let us write here H2O, water. So the products in photosynthesis are glucose, oxygen in aqueous form, and water. So this one is not difficult, but slightly more difficult than the normal one. So go to your example to make it easy for you. Just remember that in photosynthesis, there are two reactants, carbon dioxide and water. The green plants take these two reactants and produce glucose, oxygen, and water. So remember, reactants are 6 carbon dioxide and 12 molecules of water, okay, in photosynthesis. So memorize this or keep it in your memory that this is balanced. This is the right number. 6 carbon dioxide reacts with 12 molecules of water, 6 molecules of carbon dioxide. So this is correct, and use this one to balance on the right side. Don't memorize these 3, okay? And then another thing I'll tell you as we balance, it'll make it a lot easier. It's slightly harder than the normal one, so better memorize the reactants because there are only 2 reactants, carbon dioxide and water, so it's better to memorize only 2, 6 and 12. If you memorize 3 things, is harder. So on the left side you memorize and use that to balance the right side. So let's start with C. 6C here, no C, here also 6. So 6 carbon atoms, and the right side also equal. Let's go to O. Then O here also is there, here also is there. On the right side also O is in everywhere. So when a particular atom appears so many times, it's more difficult to balance normally. Okay. So what do? We go and check the next one. Hydrogen appears only once here. Oxygen appears twice on the left side, but hydrogen appears only once. On the right side also, hydrogen appears only twice. So it will be easier to balance the atom which is appearing or occurring lesser number of times. So to balance in so many places is more difficult. So we prefer to balance the hydrogen first, even though oxygen is coming first. Skip it and go to oxygen. 12 to hydrogen. 12 twos are 24 hydrogen atoms on the left side. At only one place. Here at 2 places, but we can use your common sense. We just now said this 6 and 12 cannot be changed. It's already balanced. Correct. So carbon is not here. So 6C means here also carbon, not here, not here. So already 6, so we cannot put a number here, which means this nothing needs to be done to balance this because 6 carbon match. If you disturb with 2 and all, it will get disturbed. So we know this need not be changed. So our focus will not be here, our focus will be here, because hydrogen is here and here. So we will not touch the hydrogen here to make it 24. So here 2 plus 12 is only 16. So how do we make it? 6 twos are 12 plus 12, 24. So we make it 24 hydrogen atoms like the left side by balancing this one and not this one, because this is already balanced, 6 carbon atoms C. Then finally you go and check oxygen, you will find out it's almost already balanced. 12 oxygen plus 6 twos are 12, 24. 6 twos are 12 oxygen plus 12 ones are 12, 12 plus 12, 24 oxygen atoms on the left side. Balanced, we know 6 and 12 is balanced, so that's correct. It cannot be more than 24 on the right side also, therefore. We cannot touch this. This is also already balanced just now. So we have to option here to balance. All 6, and here 6 1s are 6, 12. Another 12, we need to make it 24. So how do we make this 12? 6 2s are 12. 12 plus 6 2s are 12, right? And then, not this one, sorry, 6 2s are 12. Then 6 plus 6 1s are 6 plus 6, 12 plus 12, 24 oxygen atom. So as I said, in this, you memorize the left side, 6 carbon molecules of carbon dioxide and 12 molecules of water in photosynthesis. No, this is surely the correct one. Use this to balance the right side. And second thing we remember is, we balance hydrogen ahead of oxygen. Why? Because hydrogen appears only once on the left side, and on the right side only twice. But oxygen appears twice on the left side and 3 times on the right side, which will be more difficult. So balance the hydrogen ahead of oxygen, and finally balance the oxygen by using your common sense. I hope you're getting it right. So here, next is, we'll go to the next class. So in the 6 more equations are there in this test 1A. Next class, okay?